Good morning, everyone. Welcome back. Hope everyone is doing all right. Hope everyone is enjoying the day so far. Morning, afternoon, evening, wherever you may be. Hope you've been enjoying the series so far. I've certainly found it enjoyable to deliver this to you, and I hope you've enjoyed watching me struggle a bit sometimes, and but ultimately try and deliver some form of programs through the series. So I hope you've enjoyed it. I hope you found it helpful. Maybe it's come up in some of your um, daily school, daily work, other projects you're working on. Hopefully it helps. Again, keep letting me know in the comments what you think. Really grateful for that. So today, continuing on the same vein, a subject that I've known about for, I suppose, years, maybe a lot of other people know about this. It's the look and say sequence. So the look and say sequence is a series not necessarily defined by any axioms. There are no arithmetic or geometric rules. Each series value describes the characteristics of the previous term. So each term has a frequency and a digit, or a quantifying term and an item. It's a verbal pattern, i.e., you're looking at each of the series values and you're describing the characteristics of it, quantifying it. So this was I don't know how long this has been around for, but the mathematics of it has been popularized by the British mathematician John Conway in 1986. Most likely he heard about it from someone else, but he wanted to be the one. He was the one that, let's say, popularized it. Emphasis on the word popularized. Gave the axioms meaning, gave the properties a bit of structure, gave scrutiny to the characteristics, etc. He looked at the exponentiation, studied the different terms, formulated the audio active decay thesis, and others. So how do we actually define this? What does this even look like? If I go down here, so we've got the first series value typically as 1. And what is 1? It is simply one lot of the digit 1. What is 1, 1? It is two lots of the digit 1. What is this? It is one lot of the digit 2, followed by one lot of the digit 1. And we can keep going on this fashion, but you can see it exponentiates, and the digits they accumulate to a very large number. Just carrying on a bit there. So what is that? That's one lot of 1, one lot of 2, and this final is two lots of the 1. And you can see it for every continuous string of the digit. That's what we count here. So here we've got 3 lots of 1, then we've got 2 lots of 2, we've got 1 lot of 1, etc. And we simply keep going with this. There's no terminus to this. The rules are, or lack thereof. There is only one rule. It is straightforward and it is stringent, and you can carry on ad infinitum until you've exhausted, or the computer at least will run out of memory. So this will be useful going forward, and I will keep that there as we will. So with the forward slash, this will render this unreadable by the script. The forward slash or the backslash? I asked this question before. I still haven't found out the answer. I've mentioned somewhere as well, learning from my mistakes. This is one that I haven't, but anyone in the comments, let me know. Is it forward or backslash? So anyway, we don't need to keep going on and defining these series values, because we're going to create a script today that'll do exactly that. So let's try that. Today is it's August 5th today. It's August 5th, 2025. It's Tuesday, and let's get on with this. So let's semi-clear the board. I want the look and say sequence to remain. So let's do this. So using system and create a class. Okay. Good. So I'm going to define the rules first. So what are these series values? They're strings of digits. I'm going to define first this get next term, and that's a string, that's an input there. Okay, and I want to define the rules. So this string result will set up a means by which we can it paves the way to running continuous result, right? It starts an empty string and paves the way for more outputs. Okay, and we're starting the count from 1, so every digit will start from 1, or every count will start from 1, whatever that means, a 1 or a 2, etc. So for int I, as long as so starting from I, and as long as the I is less than that input, what we want is the length of all this. Spell correctly, please. Length, and this will keep going on forever, or as long as there is something to count. Okay. Next, what are the actual rules here? So, what are we actually looking at and what are we observing? If so, what input? So, the input to the current series value. Oh no, sorry. The For the current series value, we are evaluating each of the digits. So each input I minus one. And what this is saying, well, let me complete that first. Count plus plus. What this is saying is for each digit within the string, if the current digit is equal to the previous digit, then we will simply keep counting it until it is not the same digit. So here we had this 1 1 is the same, the next digit is the 1. However, the 3 is not the same as a 1, so we stop counting when we hit a digit that is not equal to the previous digit. So in that case, we get 3 and a 1. So the quantity is the 3, the counting item is the 1 in that example I said. So else, so what happens if it's not? Then what we need is another rule. So what is the result there? So this is the sort of the output of that result. So we're going to, that's the counting number, 2, and the string there and there, plus input minus the 1 there and there. Yep. So going back, you'll see I'm using this double equals and this double plus equals. So we when you see the double of the equals or the plus or even the minus, we're using that in conjunction with an if. So we're not simply saying, we're not making a statement. We're not saying that the current integer, the current digit must be the same as the previous digit, but there's a statement here. Equals is allowing for that. Similar here, the else. We're still sort of running on the if function here. So we've exhausted the actual primary if, and now we're on to, let's say, the second if. The result here is two things. So whenever you see the plus, that means we're combining more than one thing. Okay, so once we've done that, we want to start again the count. So this is fine. This is the rule here, and I don't think this is going to give us anything. And I think if I run this now, it's going to say we don't have a static void to run this against a static main. Sorry. So there we go. A static. We don't have a static main. Okay, so now we need to create a static main, but I don't think we're done here yet. What is the actual result here? So the result here is a digit. So it's the counting number or how many of the digits combined with the actual digit. So concentrate, so input dot length minus 1. Yes. So what do we want? We simply want to return that result. So I'm not sure if this would give us any, I'm not even sure if we return the same error message. Okay, the program does not contain a static main method root. Okay, yeah, so all right, we need to create a means by which we can output in the console. It's all very well and good that we've created this rule, but how do we actually communicate that with the output? That's what we need to do now. So I'm going to create a second static, and this is the actual console output that we want to work with. Static void main, that and that, create another loop. So here, what do we want this to start with? It is typically 1. So remember that 1 here points to that 1 over there, the first series value. So while true, so the while true is, how do I describe it? It's in conjunction with the fact that there is no termination to this series. This will keep on carrying on. You'll keep on cycling through these results, and there's no endpoint to it. So that's what the while true is. You simply keep on going. So now I believe we only want a stack of console write lines by some means. So if I write the current, so this is the console write line is the current string that I wrote here, the current. However, we need that to cycle through. We need to move that to the next point. I'm going to write another console write line to separate all these values. Otherwise, they will coalesce together. Going to be very unhelpful. And so here, what do we want? The current term will instantly be replaced by the next term in the series. So that's what I'm writing here in this line 13. And now let's add a bit of threading as well. Otherwise, we don't want this to run or to output all at once. I think the console might crash, but I think it might do anyway because this is online. And what do I want this to run? Do I want to run at 1 second? No, let's simply output it at 1,000. No, half a second, sorry, half a second. Um, okay, so I'm going to copy this because I'm anticipating what I'm going to do next. So let's run that. Let's see what we get. Great. Okay. 111. I think this is I've got first time 111. Yep. Okay. This looks good. And this is going to keep on going. You can see, there you go. Couldn't, I don't even know what these numbers are. 1, 11, 22, 1,211, 111,220. I can't even count these. Does anyone know how to pronounce this number? How do you say that? And this will keep going, and you can see what exactly is going to happen. And look, the numbers simply exponentiate. They cascade with too many digits to even work with. Don't even know how to pronounce these numbers. Um, it keeps going. That's it. And look at that. Look at that. There's marvel in this thing. It's it makes. Okay, so there you go. I'm not even going to try and quantify it, but here we've got the numbers. Okay, so you can see. Look at that. It starts off manageable. I don't know when this starts to get out of hand, or when this starts to not be able to. You can't even pronounce these numbers, but it simply exponentiates unmanageably. And then we get two lines of digits, and it carries on. That's it. That's all this is. How cool is that? That's really interesting. I really like this. Great. So these there are a lot of digits. And say the exponentiation. That's kind of let's try and quantify that. That will be consider that the next part of the series. So I'm not going to quite. You can see it exponentiates, but to what extent is the exponentiation? So let's do that next. Okay, so let's consider that the next part of this. Okay, so let's try and output this. Okay, so what do I want? I'm trying to think forward. All we want to do is count the digits. For each of these series values, we want to count the digits. So I don't. Let's try and. I don't believe that. I don't need that. I don't need the actual console write line because I'm not outputting digits anymore. So what do I want? Okay, so let's try again. So for the int, let's define this. This int length that I'm writing out here is the current length. This is simply storing each of the values. Okay. I'm going to write this on another tab. Okay, so int length current equals the current length there. Okay, so that's recalling and storing. We don't want it to output it, it's simply storing it. Okay, and how do we want this to be outputted? I want a string formatted here. Correctly spelled. And this will quantify the length here, but it's going to communicate with this the output, meaning what's it going to say? So what is the string? I want it to simply say what is in the string. So the toString, there's a few parts to this, so let me write this out first. The N0 culture info, and what sort of culture info is. I want an invariant culture. Is that spelled correctly? Close that and plus there. And we want, how many digits are these? So if the length of the actual digit is equal to 1, so notice that we're using the double equals as well. So if there's one digit in it, then we want it to output a digit. There is only one digit to this. Otherwise, we want to use digits. Okay. Okay. So I mean, really, there's only going to be one end to this because there's only one digit, one series value with one digit, and that's the first one, one. Okay, so that's what this is, and I've dabbled around with this for a while. I have no idea why we use that question mark in this syntax. I have no idea why we use this colon here, so I'm bearing with it for now. And because we're outputting the digits, let's simply put an X there. We're counting them. Okay, so you're probably wondering, I've used an output here with a plus, and I'm combining a few things together to make this. So why am I not using like a plus equals there? And I think it's simply because these aren't what I'm actually using in the string format are not, let's say, objects that I'm defining. Let's say, well, I think they are actually. I'm going to leave that for now. I can't quite explain that. So one final thing is the console write line. Yeah, the formatted. Okay. So I've defined the formatted here, but I actually want to output that in the console. Okay. Same threading. And so I learnt this a while ago. So whenever you're using a file culture, or whenever you're using some sort of um, date or some sort of I'm not sure how to describe that. But whenever you're working with certain types of dates or numbers or groupings, a collection of data, you want to use this package globalization, the system globalization. So I'm going to input that in there. So what is this again? It's X, the two string, the N, that's an N0, by the way, not an NO for no. So for these digits being outputted, we don't want them to output decimal places. So no decimal places here. And a culture info area, what that culture invariant culture is simply saying, I want each lot of 3 digits to be separated by a comma. That's all. Okay, so let's run that. That should be fine. Have I still got the series values there? Yep, so it's not going to output those series values. It's only going to output the count of digits. Great. So there's that X that we saw. There's the actual count of the digits. There's the digit for the Boolean logic that we provided. It's either digit or digit. And there's that comma there. We're separating every 3 lots of digits with a comma. So maybe if that gets large enough to 1 million digits or so, I don't think programmers will output that. So there we go. So what is it? How do we even define this? So we've got 1 million. Why have we got 6? That's right. Yeah, sorry. We've got 1 million digits here. We've got 1 billion digits here. We've got 1 trillion digits here. And we sort of smashed through from 1 trillion to 1 trillion, 1 quadrillion, 1 quintillion here on 20 digits. We simply smashed through that. We smashed through the heptillion as quadrillion, heptillion, quintillion. We smashed through heptillion to septillion, and this simply keeps on going. 100 digits, that's, I believe, what you call a googol. Googol. A googol is 100 zeros. We don't have 100 zeros, but that's the closest we can quantify this with. 100 digits. A googolplex is a 10 to 1 googol, lots of digits. I don't know. I believe that's 1,000 digits. Someone help me out in the comments. And the largest number I could actually find here is 10 to 300 digits. So I'm getting a bit confused as to where that actually aligns here. But we've easily smashed through all of those definitions here. These are seriously large numbers here. And maybe if I actually had, I know someone's gonna say this, but I know if I used Visual Basic at actual C#, that I might actually have a chance of producing a lot of these values. I'm getting there. But you can see here, these are seriously unworkable, unmanageable numbers. Good. So let's, you can see, yeah, they are exponentiating. So the next part is, how, can we find out to the extent by which these are exponentiating? By that, this was where John Conway, his part of his research was finding out the constant growth term, or the growth term is certainly not constant. So how many more digits are added on, or by how much does the length increase on top of the previous number? So what we want to do is this number of digits divide by this number of digits, this number divide by this number, etc. And that should tend to a certain number. Now, spoiler alert: John Conway figured that out to be 1.305 something, 1.303. I had it written down there somewhere. So basically, each digit is extending by 30%, or adding another 30% of digits on top of that. So let's try and output that. And I'm going to copy that, and I'm going to do this in another tab. Okay, so let's finish that off. I don't need that. I don't need that. So what do I need? I'm hoping this will be straightforward, but knowing me, it's probably not going to be. So I'm going to need that current term here, but I wanted to find out here because we need, reason why I'm moving up here is because we kind of need both the current and the previous terms. And so I want to be able to recall the previous term. So the previous length, right? Let's define that previous length is equal to the current length. And what that's doing, again, it's saying we need the current series value, but we also need the previous series value. So every time we move along, the previous value will remember the current value. That's probably not the best way to say this. So what do we want to move forward? We want an integer here, the current length that we've defined up there, current length. is equal to the current length, the length of digits of the current series value. And what is that we actually want? We want what I said earlier. We need to calculate the growth term is the number of digits in the current series value divided by the number of digits in the previous series value. And so remember, we're using this double here because we hopefully want to see some decimal places in here. And so when you're working with decimal places, you're going to want to use this double. Okay, so that's the fraction, the quotient that we're working with, and so we want another string here. So the formatted string, or how do we define this format? I'm going to go along the same vein using the number of digits ratio.to string, and this time I'm going to want, let's output this to 5 decimal places, 4 decimals, 5. That should be a good amount. The culture info as well. I don't think we'll be outputting groups of 3 decimal places or 3 digits because these will be decimals now, or you'd hope they are. Well, I told you anyway that they should be. That was John Conway's great result here. So I need a means by which each of the previous series value will revert to the current. Yeah. Okay. So this is what this is: current length. So that should be it. Is this right? Once over. Looks correct. Okay, so let's separate that. Does that work? No, previous length does not exist in the current context yet. Why not? The previous length equals that current length. Yeah. What is previous? Oh, I've used I think it's a mix of capitals and series. Yeah, so I defined a name. That's a lowercase. That's a lowercase. That's a lowercase as well. So, okay. Good. Okay. 2, 1. Yeah. Okay. 1.3. So that's close enough so far. 1.30. There we go. Great. Look at that. Good. Before we go on, while those output, you'll notice here that the rules here that we define for the look and say sequence, we have not changed this. This has stayed intact throughout. It's this get next term function which is aligned with the definitions here or the rules here, and so that get next term is it's inputted here. That's set or that's, let's say, the storing in memory the current series value. So we haven't changed this, so that's great. We can do all of these functions once we've laid out the rules for the look and say sequence, and then we can do other things here with them. As long as we have that one core definition, perfect. So what is it? Do we get that 1.30 that John Conway gets? I'm sure in time we'll get there. John Conway had to do it the hard way. I don't believe C# was around at this point. I think Java was. C, MATLAB, I'm not sure. Someone in the comments, maybe there's a timeline for all of these programs here. Someone help me out in the comments. But John Conway, unfortunately, he didn't have programmers. He didn't have Visual Studio. So we do. So we can this is what we can use it for. This is rather fascinating and certainly gives credence and gives credence to John Conway's discoveries. So I'm going to leave this here. I'm going to end this video now. I hope you found this useful. I've got one more thing left to do on the look and say sequence, so I'll leave that for another video. But again, yeah, I hope you found this interesting. This has certainly brought back memories for me looking at the look and say sequence again. Truly fascinating. Yeah, if anyone is studying the look and say sequence, or if anyone is curious, has any questions, let me know in the comments what your thoughts are, and on the script as well. As always, it's a learning curve for me, so yeah, let me know if anyone has any suggestions, criticisms as well. I'm always happy to suggestions. I'm always happy to learn and off your comments, so let me know. Apart from there, I hope you enjoyed it, and I will see you in the next video. It is August 5th today, 2025, Tuesday. I'll get this video uploaded soon. Thank you very much. Hope you enjoyed, and I will see you. I'll see you in the next video.